this is a polynomial, what are the pieces that I need to graph as well? So page 134 and 135 of the E or hard textbook will give you a nice suggestion of a list basically of things they recommend you do, but it's basically all the things we've been doing. Determine what the end behavior is by looking at the degree and the sign of the leading coefficient. Find your x-intercepts, and of course what that means beyond just finding them, what's happening at them, right? Are they touching, are they crossing, based on the multiplicities. Find the y-intercepts by letting x equal 0. One thing we haven't reminded ourselves of or made ourselves do yet is these two. This is back in the day when we didn't have any graphing utilities, Desmos software, graphing calculators. We were literally just trying to sketch a beautiful graph by hand. Okay? If you were doing it by hand and you wanted it to be excellent, you would need to think about symmetry. Remember in your previous algebra classes, we found out that some graphs, very few of them, but some graphs do have y-axis symmetry, meaning that when you change the signs of the x values, you get the exact same y value. Okay? Other graphs do have origin symmetry. From quadrant 1 to quadrant 3, quadrant 2 to quadrant 4, they're reflecting over. That happened when I changed the signs of my x values and my y values changed signs as well. Okay? So if one of those two cases is happening in a function, a polynomial function, then once I know one piece of one quadrant, I know another. So I could get a beautiful picture by recognizing symmetry. So this is saying if you had no sort of graphing utility, no sort of software, and you wanted to sketch a really nice graph by hand, which you may need to do going forward wherever you study calculus, using symmetry would be a fast way to get another quadrant once you have one. Test signs are also really helpful. You're going to be doing a lot of that in calculus. So once you have those x-intercepts, if you want to know what's happening to the left of the x-intercept and to the right of the x-intercept, for example, am I above or below the x-axis? You could simply check the signs, right? Am I negative or am I positive when I go left and right? And if I get a negative result when I put in a number as x, that means I'm below the x-axis. And if I get a positive result when I plug in an x value, that means I'm above the x-axis. And I can then have a better picture in mind. So these are basically really nice if you're trying to get a great picture by hand, okay? But for a basic sketch, just the first few will suffice, okay? So let's do a basic sketch in our next slide together. We'll just have you do B, because A is too easy.